Okay, everybody, I'm making my first video with my new headphones. I'm kind of excited about it. Hopefully it'll be better sound quality. The first problem I have here is I want to express the product of 2x squared plus 7x minus 10 and x plus 5. Well, my favorite way to do this is using the box method, and I'll write out 2x squared plus 7x minus 10 up top, and then x plus 5 down the side. Doesn't really matter which way I do it, but I'd prefer to work with a box that looks like this versus a tall vertical box. And each row and column intersection is where I'll put the products. I have x times 2x squared, 2x cubed. Remember, we add the exponents when we multiply like variables. Plus 7x squared. Notice I put the sign in there. Minus 10x. Now we'll distribute. Basically, it's just an organized way to distribute your work. I'll distribute the 5. 5 times 2x squared is 10x squared plus 35x minus 50. I personally see it's much easier to get my terms that can be combined. They seem to line up nicely here. So I will write them out to the side here as 2x cubed plus 17x squared plus 25x minus 50. Our next problem, we'll subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. Because it says subtract from, that means this goes first. Very important. 3x squared plus 8x minus 7. I'm going to subtract the entire polynomial, 5x squared plus 2x minus 11, which requires parentheses. So there are two places to trick us in this problem. The from, which tells us to switch the order, and the subtraction. I'm basically going to be distributing a negative 1 here. So I'll write down 3x squared plus 8x minus 11. I'm dropping the parentheses. Now I'm distributing that negative 1 to all three of those terms, which all it means is I changed the signs. So when we combine these terms now, the x squareds can be combined. I get negative 2x squared plus 6x, and the constants become plus 4. Be very careful with your signs. 3 was very similar. I won't go over that one. Number 4, I promised to go over. The length, width, and height of a rectangular box are represented by 2x, 3x plus 1, and 5x minus 6 respectively. When the volume is expressed as a polynomial in standard form, what is the coefficient of the second term? Well, volume equals length times width times height. The product of all three of those polynomials, 2x times 3x plus 1 times 5x minus 6. So really all I'm going to do here is find the product of all these terms. I'm going to multiply the two binomials together first using the double distributive property. So I'll bring down the 2x, but I'll leave it outside for a moment. Get 15x squared minus 6x. Excuse me, it's not minus 6x. It's minus 18x. Then I'll distribute that 1. I love distributing a 1 because it's very easy. Plus 5x minus 6. I combine these two terms in the middle that can be combined. I now have 2x times 15x squared minus 13x minus 6. And my last step is to multiply this entire trinomial by 2x. 30x cubed minus 26x squared minus 12x. Now the question, all it asks for is a polynomial in standard form. It's a decreasing order of exponents. What is the coefficient of the second term? Well, it's the negative 26. The negative 26. Because you got to read the directions, the second term. Okay. That's just a simple factoring question. Number 6. It says equivalent. I'm going to go over this one just because it makes sense to go over it, because I haven't done one with an equivalent yet. X to the 4th minus 16. Well, if I'm going to start factoring this, this is a difference of perfect squares to start with. So I'll write out two binomials and put the square root of the first term in there, in the first spot, square root of the second term in the second spot. Then I'll put a plus and a minus. Okay, well, I look at the choices. I factored x to the 4th minus 16, and I got this. Although I haven't factored it completely, they are equivalent. It's finished. I'm done. It actually was a double DOPS. I could have done a DOPS again, but I didn't need to. Number 7 I found to be rather tricky as well, because it asks you for what's equivalent. Well, what's the first rule of factoring? The first rule of factoring is we don't talk about factoring. That's not true, actually. The first rule of factoring is GCF. But if you're a Fight Club fan, you'd appreciate that. GCF of 16x squared minus 36x, minus 36 is just 4. So I'll divide by 4 and get 4 times 4x squared minus 9. Well, 4x squared minus 9, that's a DOPS. Now, if you didn't take the GCF out, you still had a DOPS, but a difference of perfect squares. But there's our answer. There's our choice, choice 2. Now, some people might have saw this, 3 and 4, but notice the signs aren't different in each one. We'll skip 8. I said I would do a couple like 9. Well, this is where I'm probably going to slow down a little bit. I want to use the AC method. Remember, it's ax squared plus bx plus c. Well, this means a equals 2, b equals 13, and c equals 21. A times c is 42. I want factors of 42 that add up to 13. Well, luckily I see that it's positive, and that's positive. It's my favorite one where they're both positive. Let's see, factors of 42 that add up to 13. 1 and 42, no. 2 and 21, no. 3 and 14, 17, no. Bit closer, 4 doesn't go in, 5 doesn't go in, 6 and 7, hey, that's 13. I'm pretty happy. We'll split the middle term. Remember, when the leading coefficient is something besides 1, we can't just throw in these two numbers. We have to split the middle term. 2x squared plus 6x plus 7x plus 21. We draw a line down the middle, and we factor. The GCF between these two terms is 2x. If I divide by 2x, I see what goes in this quantity here is x plus 3. On the second term, the second group of terms, the GCF between 7x and 21 is plus 7. Now notice I followed that sign there to know that I'll have plus 7 is my GCF. Inside the parentheses, I get plus x plus 3. Awesome. X plus 3 is a GCF. So we have x plus 3 times 2x plus 7. That's my answer. If I wasn't feeling confident, I could check this. 2x squared plus 7x. That's when I distribute the first term. Distribute the second term, I get plus 6x plus 21. Hey, 2x squared plus 13x plus 21. Very nice. Let's do number 13, or number 10 since we have time. 3 times x squared minus 20x minus 7. Let's see, we need numbers that multiply to negative 21, add up to negative 20. Because a was equal to 3, c was equal to negative 7. So AC was negative 21. Let's see here. I see 1 and 21, negative 21. 1 plus negative 21 adds up to negative 20. First try, I'm a lucky guy. 3x squared minus 21x plus 1x. I'm going to put that 1 in there because I might see the GCF a little easier that way. Minus 7. Split down the middle. The GCF between 3x squared minus 21x is 3x. Take a 3x out. We have 3x times the quotient inside here. 3's cancel. X squared divided by x is x minus 7. Over on the second pair of terms, 1x minus 7, the GCF here is just simply a 1, and in fact a positive 1. So I have plus 1 times x minus 7. And happily, these are the same things, same binomials, I should say. X minus 7 times 3x plus 1. If I chose to check this, which I will, let's see, 3x squared plus 1x minus 21x minus 7, 3x squared minus 20x minus 7. Yeehaw. Factor completely. If you see factoring completely, it means you're likely going to have at least 2 steps. And again, our first rule of factoring is not to talk about factoring, but after that we do the GCF. So, what is the GCF between these two terms? I see a number of 2, because 2 goes into all those 3 even coefficients, and they also have an x. So 2x is the GCF, because 1 is the lowest exponent of all 3 of those that they all have in common. So I pull out a 2x. My result is x squared minus 2x minus 35. Now this is one of the easier factoring polynomials because the leading coefficient of this trinomial here is just 1. So I need numbers that multiply to negative 35 and add up to negative 2. Right away I say, well, it's not 1 and negative 35. How about negative 7 and positive 5? We got it. And at this point, because I know the leading coefficient is just 1, I can say this is 2x times x minus 7 times x plus 5. Okay. Thank you so much for watching. Hopefully this helped you study.